Unit 2, Lesson 6, Equivalent Equations. So today's goal is to investigate what makes two equations equivalent. So we have two equations or two expressions here, and we are going to figure out what our answer is after we substitute in 5 for n. So we're taking n and we're making it equal 5. So we do 5 squared minus 9 all over 2, 4 minus 3. Okay, so PEMDAS is parentheses first. So that is 4 minus 3, which is 1. Exponents, which is 5 times 5, which is 25. Okay, now we are left with multiplication and subtraction. We can do those all at once. So we get 16 up at the top, and we get 2 at the bottom, and then we get 8 as our final answer. Okay, now we hope that we get 8 for our second one as well. So we're going to do 5 plus 3. Remember, we're putting 5 in as n. Multiplied by 5 minus 3 all over 8 minus 3 times 2. Okay, parentheses, 5 plus 3 is 8. Up at the top, we can do 5 minus 3, which is 2. And then at the bottom, we need to do the multiplication first. So that becomes 8 minus 6. Okay, so we get 8 times, keep the 2 on the top. 8 minus 6 is 2. This simplifies to 1. And 8 times 1 is 8. All right, we got the same. Yay! Okay, we're going to try it again for -1. I'm going to have you guys do this one, and then we're going to figure out what you get. So take out a piece of paper, substitute in 1, and then let me know what you get. Okay, now let's check your answer. We're substituting in -1. Okay, -1 times -1 is 1. Then we get 2 times 1. 1 minus 9 is -8. Divided by 2 is -4. -1 plus 3. Okay, so again, parentheses first, -1 plus 3 is 2. And then up top, we have -4. And on bottom, we have to multiply first. That gives us 6. Okay, so we get 2 times -4 over, take away 2, it's 2, then we divide. That's -2. And 2 times 2 is 4. 1 positive, 1 negative, so good, -4. Yay, they were the same. So what does that mean? Were you surprised that these expressions have the same result for different n's? So the first n was 5, and we got the answer 8 for both of them. The second n was -1, and we still got the same answer for both of them. So what does that mean? That means these two expressions are equivalent, which means we can make it an equivalent equation. So if we just put an equal sign right here, bam, equivalent equation. So we take the two expressions and we're like, bam, they're equal. And then you're just like, whoa, yo, bro, that's so cool. Yes, I know. So they are equations that have the exact same solutions. These are called equivalent equations. So we're going to talk a little bit more about those. So this one, it says, are any of these equations equivalent? Yes or no? And if so, which ones? So go ahead and take a second and select either the first, second, third, or fourth. All right, so what did you guys decide? Let's take a look. So we got 3a plus 6 equals 15. We got 3a equals 9. We got a plus 2 equals 5. So I'm going to try to solve for a, see what we get. So subtract 6 on both sides. We get 3a equals 9. Oh, wait a minute. Look, this one's already equal to that one. I'm going to keep going. Divide by 3. A equals 3. Okay. Spoilers, this one's going to be the same. We already know that. We saw they look the same. A equals 3. Cool. Ooh, subtract 2. Wait a minute. Oh, look at what they did. They're all the same. What the heck? So all of these are equivalent equations. They're all equal to each other. What the heck? Okay, let's look at another one. It says, how can we show that a is equal to 1 is equivalent to a, or 3a is equal to 9? So how can we show that these two are equivalent? What is something that we can do? Okay, well, we can solve for a. So to solve for a on the first one, that's already done. For the second one, let's divide by 3. Aw, are they equivalent? No. The other thing I could try to do is I can multiply this side to try to make it look like the other one. So let's try that. Let's multiply by 3. So we're going to multiply 3 on the left, and we're going to multiply 3 on the right. So 3 times a is 3a. Looking good so far. Then we're going to do 3 times 1. Oh, that's not 9. Oh, now we're sad. They're not the same. So these ones are not the same. They're not equivalent. Okay, let's review some words. So what is an equation? That's a math statement that has two expressions that are equal. How or what is the solution to an equation? It's any number that we can put into that equation that will make the equation true. And then how do I see if a number is a solution? So if I give you like x equals 2, how do I check to see if that is an answer or not? So what you would do is you would take 2, put it into that equation. If it makes your statement true, then great, it's an answer. However, if you put in 2 and then it gives you a false statement, then that means it is not a solution. Okay, so what can we do with equations? Some of this stuff you guys might remember from last year and even possibly the year before. So we have an equation here, and students are trying to manipulate them, but they're not sure if all of the moves that they are taking are allowed. So we have to go through and double check. Okay, so for the initial equation is x minus 0.1x plus 2.70 equals 56.7. Weird numbers, I know, but it's okay. So first we're going to look at equation A, student A, and it says what is done? And it actually tells us they changed it so the price is expressed in cents instead of dollars. Okay, so the one up here, this is dealing with dollars, but they changed it so it's in cents now. Is that okay? Are we allowed to do that? Yeah, we can do that. That's allowed. That's fine. We just take everything and we multiply it by 100. So 1 times 100 is 100. 0.1 times 100, you could just take your 0.1, multiply or move it 2 decimal places. 1, 2. That becomes 10, so that's good. We take 2.7, again, move it 2 decimal places. That becomes, or sorry, 270. Yes, that's correct. And then this last one, 56.70. Again, 2 places, 5,670. So yes, this one is okay. And then it's saying, will it give you the same solution? I mean, if you're multiplying everything by the same number, of course you're going to get the same solution. Okay, let's try the next one. They subtracted 2.70 from both sides of the equation. So they went up here and they subtracted 2.7 from here and 2.7 from here. Is that allowed? Yeah, that's allowed. That's okay. That, as long as whatever you do to one side, you have to do to the other side. Okay, let's take a look at the next one. It says we subtracted 270 from the left and added 270 to the right. Is that allowed? No, that is not allowed. It's all about keeping your equation balanced. So if you do addition or subtraction or multiplication to one side, you need to do that same thing to the other side. For this guy, he subtracted and he added. He was like, oh, not a big deal. It is a big deal. That will mess up your equation. It will not be the same. And then if we want, we can check to see if we're going to get the same answer for all of them. So let's check. So we have x minus 0.1 x plus 270 equals 56.7. Okay, so we're going to try 60 for all of them. So 60 minus 0.1, 60 plus 2.70 equals 56.7. Okay. Let's see how much our calculator can help us. Okay, so we're going to do 60 minus, do we got parentheses here? Doesn't look like we do. So we're going to have to do the multiplication first. 0.1 times 60. That is 6. So we're going to do 60 minus 6 plus 270 should equal 56.7. So let's see. 60 minus 6 plus 2.7 equals, haha, they are the same. Okay, so 56.7. Okay, so that one's good. Now we're going to try the next one. I'll draw a line. Now we're going to try this one. So 100x minus 10x plus 270 equals 5670. Okay, so 100 times 60 minus 10 times 60. Ooh, these numbers are much easier. So 6 plus 3 zeros minus 6 plus 2 zeros plus 270 should equal 5670. Okay, let's take a look. So we're going to do 6,000 minus 600 plus 270. Yay, we get equivalent equations. Okay, 5670 does equal 5670. Yay. Okay, one more. We said no, this is not allowed, so it should not be equal, but we're going to check. So x minus 0.1 x equals 59.4. So we're going to do 60 minus 0.1, 60 equals 59.4. This is 60 minus 6 equals 59.4. I can already tell that's not going to work, but let's check. 60 minus 6 equals, ooh, yeah, those are not equal. 54. does not equal 59.4. So no, that is not allowed. Okay. And that is it for today. So if you had a student or a friend that came to you and said, "Hey, I was absent. What did you guys learn today?" And you needed to explain to them equivalent equations, what would you tell your friend? Okay, and our goal for today was I can be able to tell whether two expressions are equivalent or not. And I know that I can identify moves that can be made that are allowed and then that are not allowed. How do you feel about today's lesson? And then what should you be doing now? You should be working on your cool down and summary. You can either do that on your digital notebook on pages 22 through 24, or you can do it in your actual textbook where it says version number 1, lesson 6, summary, and then the page that follows it. And it should look something like this. This is your cool down. So it gives you an equation and it says, what does the solution represent? So if you're solving for B, what does B mean? What does that mean in terms of the problem? And then for number 2, it says select all of them that are equivalent equations. All right, thank you guys.